Okay, so we're learning to use the unit circle to find exact trig values. That's what we just did, so we're just going to repeat it a bit. And then learning to use the unit circle to solve simple trig equations, okay? Between 0 and 360. So the first way we can use the unit circle is to find exact trig values. That's what we just did, so we should have no problem doing it. And again, all of this can be done without a calculator if you use the unit circle, which is why you would use it. Okay? And to get exact answers rather than decimal approximations. So sine of 330, look up 330 on your unit circle, look for the y value. It should say -1/2. Yes? Look up 150 on your unit circle. Tan is y divided by x. So 150, the y value is 1/2. And the x value is -√3/2. The 2's divide out. And you're left with -1/√3 for the tan of 150. Secant of 30, you know secant and cos are related, so you're going to look up cos, which is the x value of 30, just √3/2, and then you're going to flip it upside down, 2/√3. Okay. Cos of -420, so first step is to get it onto the unit circle, so I'm going to add 360, that's still going to be negative. So I'm doing -420 degrees plus 360 degrees is -60 plus 360 is 300. So the cos of -420 degrees is the same as the cos of 300 degrees. That would be your first line. And then you're going to look at 300 degrees, look at the x value, and it's 1/2. So the cos of 300 degrees is 1/2. Tan of 180, so we're going to look at 180 on your unit circle. Tan is y/x, so the y value at 180 is 0, and the x value is -1. 0 divided by -1 is 0. Sec squared of 570. So I can combine two steps, I guess. I can figure out what 570 principal angle is. And then show it being squared. 210. And then for sec, I'm going to look at the x value and flip it. So the cos of 210 is -√3/2. So the sec is going to be -2/√3. But then we're squaring that. And then we're going to square the top. So -2 times -2 is +4. Square the bottom, square undoes square root, so it should be 4/3. So that's kind of what you just practiced. Everybody good with that? I call it kind of using unit circle forwards. Now we're going to use it backwards. What happened here? Solve each simple trig equation over the interval 0 to 360. Okay, which is one loop around your unit circle. You good? So, this says, where on your unit circle is the sine of theta 1/2? Okay? So there's a few steps to using your unit circle. The first one I like to do is the cast rule. I'm looking for where sine of an angle is positive. And remember the class rule actually tells me where things are positive. So that tells me those are the only two quadrants I need to look in. Instead of looking all the way around the circle, I just need to look at the top of the circle. And I'm looking for where the sine of the angle is 1/2, meaning where the y value is 1/2. Does that make sense? I'm looking for where the sine is 1/2, so I'm looking for where the y value is 1/2. So if I pop up the unit circle, so I'm looking in the first quadrant for where the y value is 1/2. You see that's at 30 degrees. Y value is 1/2 at 30 degrees. Everyone see that? And then y value is also 1/2 the y value at 150. You see how they're colored with the same color on your unit circle? Because they're related angles. Okay? So it tells me, the class rule tells me I just need to look at the top. You could look through the whole thing, but you'll never find another y value of positive 1/2. You look at all the y values down here, none of them are positive 1/2, and none of the rest up there are positive 1/2. So that means the angles that make it true would be 30 degrees and 150 degrees. So those are our solutions. So if sine of theta is 1/2, then theta is either 30 degrees or 150 degrees. Okay, you can answer like that, which is fine, or you can go back and answer like in quadrant 1, theta is 30 degrees, and in quadrant 2, theta is 150 degrees. It doesn't matter to me which one, everyone makes more sense in your head to do it, then do it that way. Okay? All right, so now we're looking where cos theta is negative root 3 over 2. So I'm going to start with cos rule. So it tells me where cos is positive. So cos is positive here and here, which means it's negative here and here, which means there's going to be a quadrant 2 angle and a quadrant 3 angle that make this equation true. Okay? In quadrant 2, theta is going to be, where does it have an x value? Cos is x. Where does it have an x value of negative root 3 over 2 in quadrant 2? Look on your unit circle. Yes. And in quadrant 3, what angle has an x value of negative root 3 over 2? Okay. All right. Cosecant theta equals negative 2. So the first thing I would do with this is, going back to our reciprocal trig identities, I would change cosecant to secant, or sine. Sorry. So if cosecant is negative 2, then sine is negative 1/2, so that we can use the cast rule. Okay. So cosecant, I'm going to do the reciprocal function, change it to sine, but if I change cosecant to sine, I've got to change negative 2 to negative 1/2. Now I can use the cast rule. Cast tells me where things are positive, so sine is positive here, where all of them are positive, and where sine is positive, but we're looking for where it's negative this time. So I'm going to have a quadrant 3 answer and a quadrant 4 answer for theta. So in quadrant 3, sine is y value. Where's the y value? Negative 1/2. Yes. And in quadrant 4, where is the y value? Negative 1/2. 330. Okay, so you're solving. You're finding the value of theta. So the unknown in each of these is theta. You're finding the value of theta that makes the equation true. But in this case, there's more than one value between 0 and 360 that make it true. Okay, there's usually always 2. Okay? And they're called simple trig equations because, well, you'll see in the data functions they can get more complicated. Cos theta equals -1. So start off with our past rule. Cos is positive here and here, so it's negative here and here. So you'd be expecting to have a quadrant 3 or 2 angle and a quadrant 3 angle. But what actually happens if you're looking for an x value of -1? It's 180, so it's not really in quadrant 2 or in quadrant 3, it's right between them, right? So in between quadrant 2 and quadrant 3, there's one answer, and that's where theta is 180. That's where the x value is -1. Okay, so that's a different one. There's only one solution there instead of 2. But it does tell you the right area to look. So you'd be looking on this part of your circle, not bothering with this part of your circle. Okay? All right, tan's a bit different too. You can still use the past rule, so tan is positive where all of them are positive and where tan is positive. So there will be a quadrant 2 answer and a quadrant 4 answer. But remember, tan is the y value divided by the x value. So I want to know where is the y value divided by the x value -1 in those 2 quadrants. So let's look at our circle. So we're looking in this quadrant. So if I divided the y by the x, I would see that the 2's would cancel and I'd get √3 over -1. You can see that by looking at it. Here, I can see the √2's would cancel and I get 1 over -1, which is -1. Everyone see that? Whereas here, the 2's would cancel and I get 1 over -√3. Y divided by x. Okay? So the y divided by the x. So the only place I get -1 is at 135 degrees. If I go back here, the quadrant 2 angle would be theta equals 135 degrees. And they're color-coded, so I should be able to use the color coding to find which angle would be the same in quadrant 4. So if I look back at my circle, if the green spoke gave me 135 in quadrant 2, then the green spoke's got to give me the answer in quadrant 4 as well. So it should be 315. But to double check, the √2's cancel, -1 divided by 1 is -1. Okay? So 315 is the quadrant 4 angle. So again, remember tan is y divided by x. Okay? So seek, as soon as we see a reciprocal trig value, we're going to change it to either sine, cos, or tan. So we're going to change seek to cos, but we have to flip the other side as well. So cos theta is -1 over √2. Past rule says that cos is positive where all of them are positive and where cos is positive, and negative in the other spots. So there should be a quadrant 2 answer and a quadrant 3 answer. Theta equals, don't forget to put theta equals, because it's like solving for x instead of just solving for theta. Cos is the x value, so I'm looking in quadrant 2 for where the x value is -1 over √2. Jess? Good. It is. And they should be the same color and looking in quadrant 3. They both have an x value of -1 over √2. All right, so this one's a little harder because it doesn't just have cos on this side and everything else on the other, so we have to use some little bit of solving equations where we're going to subtract one on both sides first. And then divide both sides by 2. And then I go to my cast rule. So cast says that I'm positive for cos in these two quadrants, so negative in those. And I'm looking for negative. So I'm in quadrant 2 and quadrant 3. So my quadrant 2 angle with the x value cosine of negative 1/2 would be 120. And the quadrant 3, 240. Okay, H has got a lot of steps, so I'm going to give you some time to try it. Okay, so I'm 2 both sides. Divide both sides by √3. Then change cosecant to sine. And then flip this, so it's √3/2. Use the cast rule. For sine, it's positive here and here, and I do want sine to be positive. So I'm looking for a quadrant 1 angle and a quadrant 2 angle. Theta. I'm looking for the y value, where the y value is √3/2. And quadrant 1 is 60 degrees. And then quadrant 2 is 120. How many people were able to get that? Good. Wow, that's awesome. That was a lot of thinking in that one. Okay, I is similar. We first get cotangent theta by itself, so add 1 to both sides. Divide by √3. So cotangent theta is 1/√3, but we want to use the cast rule, so we're going to change cotangent to tan. So we're going to do tan theta is √3/1, or just √3. So then we're going to use cast. And we want to know where tan is positive, so quadrant 1 and quadrant 3. So we should get an answer for quadrant 1 and an answer for quadrant 3. And tan's the trickier one because I have to think through when I divide the y by the x, when am I going to get √3? So I'm going to look in quadrant 1 first. When I divide the y by the x. So half divided by, that's going to give you 1/√3, so it's not 30. That's going to give you 1. The 2's cancel, that's going to give you √3, so it's 60. Okay? And because the other one's in quadrant 3, I should be able to follow the color down. The other one should end up being 240, and we can check that. So the 2's cancel, the y divided by the x, negative √3 divided by negative 1 is positive √3, so that also works. So the answer should be 60 and 240. So 60 and 240. So remember, star here, tan is the y divided by the x. It's more thinking involved. You've got to divide. Okay? All right, 4 tan theta plus 4 equals 0. Half 4 on both sides first. And divide by 4. Casserole. Casserole for tan is positive here and here, but we want to know where it's negative. So it's going to be, there's going to be a quadrant 2 solution and a quadrant 4 solution. And I need the y value divided by the x value to end up being negative 1. Y value divided by the x value to end up being negative 1. Yep, that.
135 degrees.
Yep.
115 degrees.
Good. Anyone need more explanation about how to get those two angles? Okay. All right, great. Okay, so this one I'm going to put a little star beside. So the squared makes it, it's not really harder, just keep it in mind, okay? So first thing we're going to do still is add 3 to both sides. Then divide both sides by 4. And then we go to square root both sides to undo the squared. But on the number sign, we need to put plus or minus. And that is probably that's what everybody forgets to do. Put that plus or minus there. So we get that sine theta is positive or negative. Square root of 3. Square root of 4 is 2, so positive or negative square root 3 over 2. But because it's positive or negative, sign is positive here and here, negative here and here, and we can be positive or negative, so that means there's going to be 4 answers instead of 2. Because the y value can be positive root 3 over 2, or it can be negative root 3 over 2. And the nice thing is they'll all be related angles, so they'll all be the same color on your unit circle. So if we check the quadrant 1 for where the y value is root 3 over 2. So for me in quadrant 1, the y value is root 3 over 2, 60 degrees. So all my blue values should have, my blue angles should have a y value of either positive root 3 over 2, like 60 to 120, or negative root 3 over 2, like 240 and 300. Okay? So there's 4 answers that make that equation true instead of just 2. And they are 60 for quadrant 1, 120 for quadrant 2, 240 for quadrant 3, and 300 for quadrant 4. Okay, the plus or minus means I can be in any of the 4 quadrants. Either be positive root 3 over 2 or negative. Okay. Another squared one, 3 sec squared theta minus 4 equals 0. So I'll give you time to try that one. let's start off by adding here. Dividing by 3. Square root. Excuse me. So I get that the secant of beta can be positive or negative 2 over the square root of 3. You square root the top and bottom. But then you want to use the reciprocal identity to change sec to the cos of beta is positive or negative root 3 over 2. So the CAST rule will say that you're going to have an answer in all 4 quadrants. So you're looking for an x value of either positive root 3 over 2 or negative root 3 over 2. So positive root 3 over 2 is at 30 degrees. They should all be the red ones. 30, 150, 210, and 330. Okay? 30, 150, 210, and 330. Everyone okay with that one? Okay, and then this last one's hard too because it's just very different. It's going to take common factoring to solve. So this is the hardest simple equation that you would learn in grade 11. In grade 12, you'll do some where you're doing common factoring, but you'll also do some that look like trinomials and factor them. So that's just how this gets harder in grade 12. Not that much harder. Okay? You still do common factoring, but you'll also have some that are trinomials. Okay, so if you know it's common factoring, what's in common on this side? Sine theta, good. So sine theta times, and then you're going to divide each of these chunks by sine theta mentally. So 2 sine squared theta divided by sine theta is 2 sine theta. Minus sine theta divided by sine theta is 1. So now you've got it as 2 things multiplying together are giving you 0. And the only way that's true is if either one of them is 0, right? The only way you can multiply 2 things together and get 0 is if one of them is 0. There's no other 2 numbers that multiply together. So this is where we do our little arrows. So either sine theta has to equal 0, or 2 sine theta minus 1 has to equal 0. So you created kind of 2 little mini questions. Okay? Sine theta is 0 is an interesting one because you can't really use the CAST rule because 0 is neutral. It's not positive and it's not negative. So that means you're going to have to look all the way around the whole circle for where the y value is 0 because we're talking sine here. Where's the y value equal to 0? So give me some spots. Satisfy this. Just 0, 180, and 360. So all those places, the y value is 0, between 0 and 360. So just from this little mini equation, I got 3 solutions. Now I've got to work on this part and see how many more I get from this. So I would first add 1 to both sides. And divide both sides by 2. So sine theta is 1/2 positive. So sine is positive here and here. So I should be expecting a quadrant 1 solution and a quadrant 2 solution. And I'm looking for where the y value, because it's sine, is 1/2. So that would be at 30 and 150. So altogether there's 1, 2, 3, 4, 5 solutions for that equation. Okay? Right? Great.